Hello world! Welcome back to another CTFlearn challenge video. In this video, we'll be walking through the forensics challenge, Bobby Toe's iPad. Let's get into it. Here's a pic of my friend Bobby Toe. While he's happy to give you his iPad, he's not as willing to give you the flag. Can you get it from him? Here's an image of Bobby Toe. Alright, if you download the image they give you in this URL, you'll get this Bobby Toe's iPad PNG file. Let's go ahead and open it up and see what it looks like. Alright, the background is all black, so that kind of indicates there might be something in the background of the image. And if that's the case, we're going to go ahead and look at it in StegSolve, which I already have it open up here. And you can just cycle to the gray bits right here by just clicking once on the left arrow down here. You'll actually get what looks to be some kind of Cipher text. So what we're going to do is we're going to go ahead and save this Cipher text to our challenge directory for later use. Then we're going to come back to Kali, and we're going to run exif tool on our Bobby Toe's iPad PNG file. And if you look down here, there's a warning header that says trailer data after PNG IN chunk. The IN chunk of a PNG file is the trailer signature for it. And if you put any kind of data after that trailer signature, the PNG file will ignore it and just load the PNG image normally. So in essence, you can put whatever you want to after that IN chunk. That being said, we're going to examine what's after that IN chunk by opening up our image in HXD. So I will minimize that, as well as that, and I will open up our challenge directory here, and I'll open this up in HXD like so. We're going to do a Control F for the IN chunk, which you can just do IN like that. We'll click OK, and we can see the trailer signature right here. Then right after that, we see the file header for a JPEG image. But then we also see some bytes that are corrupting the magic bytes of our JPEG image, which is this congrats you found me, you win an iPad. Now I want to show you something really quick. Normally, if we run a tool like binwalk on this image, it would be able to actually pick up the extra files that are embedded within the image. But it doesn't. And that's because the magic bytes, which include the first several bytes of a file, are corrupted. And a lot of times these embedded file tools cannot pick up on embedded files if the magic bytes are corrupted. So all we need to do is decorrupt the magic bytes here by just getting rid of all the ASCII text there. And we'll save that. Then we'll come back to my Kali box right here. And we'll maximize this. And now we should be able to run binwalk on our image. And you can see the JPEG information showing up. Now, if you run the extract flag on binwalk on the PNG file, it won't actually extract the JPEG for some reason. And you could use the dd equals dot star technique that I've shown you in the past. But we're just going to run foremost on it since it's easier, like so. And you should get this output directory from foremost. So we'll navigate into that. And you can see that it did extract some kind of JPEG right there. Let's take a look at the JPEG image it extracted for us. And it's pretty small, so we'll zoom in on it. And it looks like a picture of an iPad that has the phrase, "Baby, don't hurt me, what is love?" Now this is not the flag. This is actually going to be the key for whatever cipher we saw at the beginning of the challenge when we went to the gray bits of our original image in StegSolve. And the cipher that it's referring to or hinting at is the one-time pad, because it's talking about an iPad, which is just a hint at what the type of cipher is. And that's probably not too tricky for a lot of you to surmise, but that actually did take me a little bit of time to actually realize, oh wait, this is a one-time pad, even though it's clearly referring to it by referring to an iPad for basically the entirety of the challenge. That being said, we need to actually grab all the necessary text we need, the cipher text and the key. So what we can actually do is we'll close that and we'll navigate back up. And we're going to run Tesseract, which is just an OCR tool to extract any kind of text from the image as best as it can anyways. And we'll run that firstly on our solve.bmp image. And you can label the output whatever you want. It'll append the .txt for us. So we'll do that. And we should have a cipher.txt like so. And if we cat that out, you can see that it properly pulled our cipher text. Then we're going to do the same thing on our key image. We'll run Tesseract on output JPEG and then our key image right there. And then we'll call that key. And if we cat out the key, We get our key in mostly correct fashion. Obviously, there's an I here where there should be an L, so we'll correct that when we actually go and paste the key and the ciphertext into the tool we want to use. So now we're going to copy our ciphertext, and we're going to go to Box and Trick. They have a one-time pad cipher decoder right here. If you just search it in the Find Tools section, and we're going to select Decrypt, paste our ciphertext in here. And then we'll go back to our Kali box and copy the key, which is right here. Paste that in there. Make the correction from I to L, like so. And immediately you can see our decrypted plain text. You think you got skills, huh? Now, this needs to be in lowercase, and it's actually missing a character. It kind of skipped over our special character there, so we will need that underscore. But we'll take this and we'll copy it, and we will paste it into Python here. And we'll add the underscore, and then we will do, I believe in Python it's .to lower, so we'll do .to lower like so. And it's not, so that means it's like that. And I'm being stupid. It might just be .lower. There we go. Sorry, I kind of forgot which one it was. That should be your fully decrypted flag and the format that you need to paste it into the submission box. So we'll copy that, paste it in, and submit. All right, if you enjoyed the video, drop a like and subscribe to the channel to show your support. Turn on post notifications to get regular injections of cyber content directly into your feed. Check out our Patreon, join our Discord, and follow us on Twitter. Links in the description box down below. And leave any feedback or questions in the comments section down below. This is Almond Milk. Thanks for watching. Goodbye, world.